Welcome to the video. In this lesson, we're going to be looking at section 10.4, where we're going to find the inverse of a function. So, first things first, the question they ask here is how are a function and its inverse related? Well, the first thing is, if you look at this chart here, is if you look at a single coordinate in one function. So if you have coordinates a comma b, its inverse of the function will have coordinates b comma a. So the values of x and y just get switched. Okay, and if you have a series of coordinates, um, all of these coordinates would have to be true or they would be flipped x and y. So that's what it makes an inverse, and that's how they're related. So if you look at these two examples, first in example A here on the top, you have a series of ordered pairs, like in this case, negative 4, 7, negative 2, 4, 0, 1, 2, negative 2, and finally 4, negative 5. To look at the inverse of each relation, again, you're just flipping around the x and y values. So that's why the inverse is now 7, negative 4. That is why our inverse for the next one is 4, negative 2. The next is 1, 0. The next is negative 2, 2. And then it works the same way like in example B. So if you look here, my input, remember my input is my x values, my output is my y values. Okay, again, just writing in x, writing in y. And if you notice, everything gets flipped. All right, as long as it gets switched around like it does, they are inverses. So in these first couple examples, again, they want you to just write the inverses of each relation. So looking at the inverse of this one's going to be negative 4 comma negative 3. Here it's going to be 0 comma negative 2. I just flip them around. This is 4 negative 1. This is 8 0. This is 12 1. This is 16 2. And then finally this is 20 comma 3. Okay. Again, you need to make a table here of inputs and outputs. Just try to keep it consistent. So to find the inverse of this, I'm just going to take everything that's an input and put it in an output. So it's going to be negative 2, negative 1, 0, 1, 2. And everything that's an output in this box, I'm going to put in an input in this box. So it's going to be 4, 1, 0, 1, 4. Okay, so now we have a function um, that it says that the function is f of x equals 2x plus 1. It says solve y equals f of x for x, then find the input when the output is negative 3. All right, so again, remember, input is your x value, output is your y value. So the way they say it or the way they word it, first thing they want you to do is says solve y equals f of x for x. So what you're going to do first is you're going to take this equation, instead of writing it as f of x, you're going to say y equals, and it's going to be 2x plus 1. And then for x, solve it for x means that you're trying to get x by itself. So here I'm going to subtract 1 from both sides. Now I got y minus 1 is equal to 2x. Divide everything by 2. That means x is going to be equal to y minus 1 all divided by 2. All right, so that's the first answer. So we solve for x. Now they want us to find the input. They want us to find a value for x when the output is negative 3. So the next thing we're going to do is now we're going to substitute in y for negative 3. So now I got negative 3 minus 1 all divided by 2, and that's going to equal x. So my second answer is I just simplify, so it's negative 3 minus 1 is negative 4. Negative 4 divided by 2 is negative 2. So negative 2 equals x. And so those are our two answers. That's what x equals um, when the function is 2x plus 1, and that's what x is equal to when your output is negative 3. So again, this is very similar, but there is probably one little bit of wrinkle here, like for like number 5. So let's take a look at that one. So again, we're going to solve for x, but before that, I want to make it y equals 4x squared. All right, we got to isolate this x, so I got to divide 4 to both sides. So now I got y divided by 4 is equal to x squared. All right, to get x by itself, I need to take the square root of both sides. All right, square root of y is just going to be the square root of y, and then square root of 4 is 2. So square root of y all divided by 2 is equal to x. So that's my first answer. The second answer is they want to find the input when the output is 4. So I'm just going to replace y with 4. So now I got the square root of 4 divided by 2. That's going to equal x. Well, square root of 4 is 2, divided by 2 is 1. So 1 equals x in this case. All right, so now what they're asking is how do we find an inverse of a function algebraically? So the first thing you're going to do is if it is in function notation like it is like an f of x, you're going to substitute it in for y, kind of like what we did with those other problems. The next step is you are going to replace x and y. You're just going to switch them around, kind of like what we did with um, those ordered pairs or those input-output tables. You just switched them. And then finally, once you make that switch, you solve for y. Okay, so looking at this example, they want us to find the inverse of it. So the inverse, first thing you're going to do is you're going to replace f of x with y. So it's going to be y equals 4x minus 9. Then you're going to make the switch with x and y. So now it's x equals 4y minus 9. Once you make that switch, now you just simply solve for y. So, okay, so now I add 9 to both sides. So it's x plus 9 is equal to 4y. Divide everything by 4. That gets canceled. So now my value for y is going to be equal to x plus 9 all divided by 4. All right, if this needs to be separated, you could even write it as y equals 1 over 4x plus 9 over 4. All right, either way. So looking at these ones, let's give number 8 a try. So again, make it y equals 1/4 x minus 1. And switch around x and y. So now it's x equals 1/4 y minus 1. So now I add 1 to both sides. So now I got x plus 1 is equal to 1/4 y. Here, we're going to multiply it by 4. And you're going to multiply this by 4 as well. So this is going to be distributed as 4x plus 4 equals y. And this is my inverse. Now, every function, um, Every function does, in fact, have an inverse, but not every one of those inverses are also going to be functions themselves. So in order for you to test that out, you can uh, do what is called a horizontal line test. So I believe if you remember from previous math classes, we talked about for a function to be a function, you would have to make sure that it passes the vertical line test. So you're looking at that function and say, okay, if a horizontal line um, crosses at more than one point, then we can say that the inverse is going to be a function. So, for example, let's look at this. So, let's say I'll give you an example of what would not be a function would say. So, looking at quadratics, let's just say something like y equals just like y equals x squared, like our parabolas. Our parabola looks something like this. I can say, oh, make a horizontal line like so. Oh, it crosses at more than one point. Yes, I agree that y equals x squared is a function, but its inverse is not a function. Not saying that it doesn't have an inverse, it just means that the inverse is not a function. So it says, consider the function the square root of x plus 2. So here, if I were to graph this, so it would look something kind of like so, taking our rules from the beginning of the chapter, it looks like h is -2, so it looks like it's going to go to the left, -1, -2. Everything else is positive. It looks like it's going to kind of go like that. So that is going to be the graph of f of x equals the square root of x plus 2. If I were to try to perform the horizontal line test here, it looks like it only crosses at one point. So I can say, in this case, that my inverse will be a function. All right. What that inverse is, we have to find that out. So let's find out. So now I got y equals the square root of x plus 2. So to find it, again, we switch it around. So it's x equals the square root of y plus 2. And so I got to take care of this. So it turns into square, square. So now I got x squared is equal to y plus 2. Subtracting 2 from both sides. That means that y will then be equal to x squared minus 2. And that is my inverse. And in this particular one, um, x would have to be greater than or equal to 0, I believe. Hold on. Let me just make sure that that is correct. Dun, 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 dun. Yeah, x would have to be greater than or equal to 0. All right, so there would have to be like a domain attached to it. Because if I chose x to be like a negative number, my original function wouldn't be true. It'd give me no solution. Sorry for the delay, but I wanted to make sure it was right. And that is being able to find the inverse of a function. I hope this helps. Until next time.